Hello, I'm Adam Miller. I do release engineering for OpenShift Online. I want to talk to you about DevOps. And DevOps is another one of those terms that's very ambiguous, and people like to overload it with definitions and things. And we'll get a little bit into kind of the definition that I'm going to follow and how it applies to what we do. Real quick, I want to do a little overview of kind of what we're going to talk about. So I'm going to talk about how code goes from origin to online, how the deployment happens, how code goes from online to origin, how that relationship is, things like that, and how the contributions kind of flow in the process. Because one of the things is origin is a community upstream, and we recognize that, and that's something we want to foster and continue to grow. But also we are a consumer of that code, so we pull from it and get back to it, etc. So what is DevOps? There's this fun little definition that I kind of paraphrase from Wikipedia, and effectively it's a software development method where your dev team and your ops team works hand in hand throughout the process. It's not devs go off in a corner and they write code, and then they hand it over to ops, and then ops is like, okay, well I have to figure out how to deploy this and manage it and things like that. Like we actually collectively get together and release engineering kind of float between the two. I consider myself a little bit more on the ops side, purely because while I can write code, I don't like to insult real developers and claim that I am one of them. So another thing that kind of comes in the ops side and has kind of flown up in the big DevOps thing is configuration management and continuous integration and deployment, things like that. So we're going to kind of discuss those things, and this diagram you've already seen. But I'm going to harp on it again for a second, just to kind of reiterate how origin is the upstream, and we are a consumer of it, but there's also this kind of other dotted line that's not really here, how patches flow back up and we contribute up there. One thing to note is that there is no code that goes from here to here, gets modified, and does not go back. We follow the upstream first motto, and actually also I want to talk about enterprise for a second. The same rule applies here. Enterprise, they take it and they snapshot it, and it lives for a longer product life cycle. But if they need a patch in here, they will patch it upstream first and then backport it. So in the architecture, and I believe Krishna and Bill are going to kind of discuss this at length later. I just want to give you a quick overview. We've been talking about this broker and this node, and there's a lot of things going on inside of them. And then there's kind of your host that talks REST API, and then you have your web app, and there's DNS, authentication, data store, etc. In here, you get split up and make your gears. Basically, the point that I want to make here is there's a lot of parts that are going on, that are moving, that the platform, this is effectively where the term platform and platform service comes from. The platform is working for you underneath the scenes, behind the scenes, underneath the sheet, etc. And in the development cycle, we have what we call development environments. We like to call it DevEmp for short. DevEmps are a single instance install of OpenShift, and this is kind of a bird's eye overview of everything that's going on inside of a single DevEmp. And that will be important in a minute when I talk about how those are created throughout the dev cycle and how the code is brought down. So we use Jenkins for continuous integration. Everybody familiar with Jenkins? Show of hands. Yes, awesome. Really hoping that was the case. Okay, so we have our Jenkins, and Jenkins will spawn a base AMI. We do this periodically in builds to make sure that we have everything up to date. Our base AMI for online is Red Hat Enterprise Linux 6. We follow the latest. I think there was like a 2-day lag between when 6.4 came out and we got in production. So we follow that very very closely. We run updates. We have a security team keeping on top of those things as well. So we have our base AMI, and then for the development process, we have a job that will take the base AMI and it will kick it off, and it will build a development environment, which is the diagram that I just showed before. It will build one of these development environments, and then it will register it so that a developer can launch an instance of this dev AMI. So they can take this AMI and they can launch, and they have a pristine, functional OpenShift online instance and self-contained. So, how the DevOps are built is the launch happens, the AMI is built, it's registered, Jenkins will launch this, and we will pull from master. We pull from the latest upstream, and at that point it will launch a set of automation scripts, and we use a utility called Tito. If anybody's ever heard of Tito, yes, I love Tito. Tito is fantastic. So effectively what Tito does is takes a Git repository and will automatically build RPMs off of it. There's like tiny little metadata info that you can throw in there. It does it based on Git tagging and things like that, and it stores data. It's awesome. Tito, if anybody does Git and RPMs together, it's fantastic. So we use Tito, and it'll go through and it'll do a build, and it creates a local repository on the dev-env, and then it will yum install from that dev-env, and then there's a set of scripts that will do an automated deploy on top of that, and then that's how the AMI itself is actually built, and that's how the dev-env will go from this kind of higher level down into the actual process where we get the code and pull it in. The only thing really that's going to deviate in this instance from Origin master is we also have an internal repo that lets us tie, that extends Origin, that lets us tie into our DNS provider, our single sign-on, our website, because our website is an extension of, and not a fork of, but it is an extension of the Origin console and things like that. So, how development happens. A developer will actually launch one of these dev-envs. They will code. They will have their own local Git forks of the upstream master repository. They add the upstream as a remote, and they rebase. So we rebase, and then we have a set of scripts that do dev-env synchronizations, and they will synchronize the local GitHub repo up into the dev-env. The dev-env will then, at that point, kick off a set of scripts that will build from this newly uploaded code a new set of RPMs, once again using Tito. If I wish I'd authored it, so I'd be like, I'm pimping. No, I just really like Tito. Anyways, so it's going to kick off the Tito build again, creating a local repository of RPMs, and we'll yum install those, and we'll yum update them. We've already pre-installed, and then you can from that point kick off our set of Cucumber tests and our rake unit tests and things like that, and it'll bring back reporting information. If you break the build, this is where you should break it on your own dev-env before you try to merge it into master. But if you try to merge it into master, we can tell you to no, stop that, because when you try to merge into master, we have Rosie, which is a build bot written by one of our lead developers. And what happens is when you have a patch for OpenShift, I say you, when we for online, this is a lot of this process is actually very similar with Origin. And there's, so, it's the same. Let me take a quick pause. The tools we use are actually the same tools that are in OpenShift DevTools. There's a Git repository for Origin. We use the same set of tools, but again, like I said, the only thing is that we have an extension on top of them because we have to tie into internal build systems. We have to, for RPMs, we have to tie into our DNS and things like that. So a lot of what I'm talking about is not necessarily inherently specific to online, but a little bit more to express that there's not some like smoke and mirror, like cloak and dagger. We're not behind some black box doing it differently. We are trying to, in every way, shape, and form, do everything as though any other member of the community would. So when you have a code change, you make a pull request on GitHub. You file a pull request. And what happens there is somebody should come in and review it. You should have a developer, maintainer, whoever, senior member of the team, another community member, someone come in and review it, give it +1. Once it gets +1, you can put what's called a merge, we call it the merge tag. It's just open bracket, merge, close bracket. The build bot will go out and see that. It will be added to the merge queue. And then it gets in the merge queue, and what happens at that point is the build bot will launch a dev-env. It will create a local Git repository. It will patch in the merge from the pull request. It will locally merge it. It will build a set of RPMs off of that. It will install them, and then it will run the tests. It will run the Cucumber test. It will run the rake unit test, etc., etc. If those pass, if you did not break the build, the bot will then merge it in. there are only 3 people who can actually merge on master. One of them's the bot, and the other 2 never merge on master because you're not supposed to. We just need to have somebody there just in case. But yeah, so everybody on the team, just as everybody in the community, we run through and we merge through the bot. We merge on GitHub. We have this dev cycle where things should happen, where you create your topic branch and then you do a pull request on it. So that's kind of how development happens. Now, refocusing a little bit on online, how deployment happens, how things, it was mentioned before that we do a 3-week cycle, and yes?
And one question, go back to Origin. Does that mean that anybody could submit a patch to OpenShift?
Yes.
Just right there, that's all you have to do?
Yes, this is exactly the process. We actually have this documented. I don't think we have this diagram. The reason I say I don't think we have it is because I made it 2 days ago. So I don't think we have a diagram like this, and I think it's a little confusing without context and like pointing and like finger waving and things like that. But yes, anybody can, and we encourage it. And again, that's kind of another thing I'm trying to highlight is that online development happens just as though community development happens. So please submit pull requests. Did I answer it, or?
Well, I guess I was just thinking out loud. Like some open source communities, you have to become a committer of a certain level before they'll take your patches or your code. It doesn't sound like that's here. It just sounds like.
No, we don't do that. As long so instead of having people have to kind of graduate, we just have another community member who is already had code accepted do a review. And once another community member who's had code accepted does a review and gives it a +1, then you merge tag. The people who have the permissions to do a merge tag is currently only known contributors. However, if you do a pull request and you get it reviewed, then all they would have to do is add the merge tag. But there's yes, sir.
So like simply having that merge tag triggers the bot.
It does.
To Jenkins review it.
Yes.
Can we just pull up a pull request and.
Yeah, actually, we'll kind of impromptu really quick.
It's not on screen.
No, I know.
Is there long-term place for this process to live? Is that going to be documented on the OpenShift.github site?
Yes.
Or
Yes.
Yeah.
I think it's already there, actually.
Okay.
There's a tiny bit there. It could use some improvement and a diagram.
So I'm trying to think of a pull request that I.
You just go to pull request and then go to closed.
Oh yeah, that's probably a better idea.
I have a pull request that's in there right now.
Is it closed?
No, it's open.
Has anyone reviewed it?
Yeah, it still needs a review.
Okay, don't do that yet.
Oh, actually, another thing I want to show really quick. This one has a test on it. I want to show that too. These are all working progress.
You can just go to your fork and stick a space in something.
Hey, just, open that one. It should be fine.
Okay.
What you'll really find is we're not afraid of doing stuff in the open.
We're not witness.
So it looks like you can see the bot automatically picked it up.
Yeah.
Right?
However, I don't think that he's one of 3 people who can merge directly, and I think he just merged. Like he ran tests. Okay,
He
so
skipped
anyways.
his code review?
No, he did the code review.
Yeah. Okay, so really quick, actually, so we have 2 tags that the bot keys off of. One is test, and the other one is merge. And a test will actually run, and it will do test results, and it will go through and run a test suite, but it won't merge. So if you think you might break the build, like if you're not quite sure, run a test. And if it passes that, then do a merge tagging and things like that. The other, however, here we go. This one has a merge tag, so
That's a really good one.
Here you'll see it. It'll see you've been evaluated for online up to blah, and that's evaluating the patch set, and then it'll go through and it'll give you it'll actually update and say what position you are in the merge queue, and then it'll actually update later. And there's two set of tests. There's one for online and there's one for Origin. And if you break builds, we say no, stop. And we kick back, and then you kind of mull it over and remerge. So that's that process. That's kind of like where you go. Did that answer? I realized that we tangented like 4 times. Did I answer questions that were asked? I'm bad at this. Yes? Good?
Good.
Okay, cool. All right. So that's kind of how that works in a nutshell. Let's see if this picks back up where I left off. It did not. Awesome. Okay, so that's how development happens. So we're going to take that a step further for the development cycle and see how deployment happens. And this is where development of online and upstream diverge. So in the first portion of our sprint, we're doing integration deployments. We have 3 environments. We have integration, stage, and production. Production is OpenShift.com, so everybody sees, what everybody uses, that our online environment. Now, architecturally speaking, which my next slide will show what the architecture is, but architecturally speaking, these 3 environments are identical. I mean, we did it on purpose so that we can replicate as much of the deployment as humanly possible. The big thing, however, is they're equivalent but not to scale. Because our production environment is obviously going to be larger than our integration environment and our stage environment, because only us, we and our QA team use it. However, at the point of stage, late in our sprint cycle, I say late loosely because a 3-week sprint cycle doesn't have a whole lot of variance, but at this point we branch. We branch to stage, and stage becomes what will become production. And the production for online will branch, but again, Origin never stops. Upstream Origin keeps going, master keeps going, people keep contributing and pushing to master. Stage is stabilized, we kind of mull it over, we fix bugs, we do things like that, and then our QA team will run through and sign off, and once we have release candidate code, we will deploy to stage. So we branch and stage on GitHub, and then we deploy to our staging environment. And then we run through some more testing, we do some more verification, and then once that is ready, we go to production. However, during this timeline, again with the code, Origin never stops, master continues to go, and anything that's fixed in stage goes upstream. Or if it's been fixed in upstream already, it gets cherry-picked and pulled and merged into stage. So that's kind of the relationship between the two, and how we continue to push upstream without deviating too much. We try to very aggressively follow it, whereas enterprise is going to, snapshot and do multiple months between updates. So that's how that goes. Now, OpenShift. Oh yeah, really quick. It's all Puppet managed. We do. It's uninteresting at this point. Everybody's got a configuration management tool. You're using Chef, you're using Puppet, you're using Salt, you're using ECFG2, Ansible. What?
Bash scripts.
Pick your poison. I note it because it is something we do, and that is a topic that falls into the DevOps category. But at the same time, we have a set of Puppet scripts that we launch each environment, so that way our deployment is as uniform as possible. And that's why I put it on there and I mentioned it. But
So there are Puppet scripts on in the GitHub repository. Are they the same ones that you're using or not?
they are not.
Okay.
Because our Puppet scripts are very heavily geared towards our environment, and there are certain things about some of our more private configs that could potentially, people could maybe deduce some information about some of our partners, and from a business standpoint, we just can't do that. But as much of what we do as we can, we make open. Yes. Okay. So, really quickly, our environment, what the actual production environment looks like, what our staging environment looks like. So we have Mongo, we have our replica set out there because we like data to not die and disappear. We have a REST API which comes in and hits our load balancers. Our load balancers then send to the broker. The broker, we have multiple broker nodes. Depending on environment, it goes up in multiples of 2, depending on which environment you're in. From there, the brokers communicate with our DNS provider, which is a partner we have. It's a cloud provider. I don't know that we talk about who it is, so I won't. But we have a DNS cloud provider. We do single sign-on, which is actually a Red Hat internal sign-on. So if you have an RHN account or an access.red hat account, you can use those credentials in OpenShift Online. We then have message bus and collective servers that are also highly available. So the brokers will talk to that. The nodes will then talk back and forth with them collective nodes to communicate with the brokers. So this is kind of our general overview architecture of what online looks like, and this is what we deploy to. So,
And then you mean ActiveMQ, right? The bus.
yeah, it runs on ActiveMQ.
Right.
But
The mCollective would actually run on the nodes themselves.
no, it runs there. Yeah.
Okay.
Should I like edit for clarity? Should I edit that? I can edit that. Oh, really quick. I want to go back really quick, just for 1 second. Something I did not mention. So in the development environments, we actually have the automated scripts that use Tito. However, before we do the deploys out here, we actually run it through our internal build system. How many people are familiar with Koji in Fedora space? Okay, so internal build systems are similar to that in some rhyme or reason. However, they're not the same. But we do tie into that, and then we do our builds, and we have an official repository of RPMs, and then when they go from integration to staging, they graduate. So the code base graduates to get from one to the other. And then it graduates from staging to production. We have a set of RPMs that we actually send through our signing servers, and they get signed and blessed, and then we deploy them to production. And we have 24/7 ops team who monitors and manages all these things. We actually monitor with Zabbix. If anybody's maybe a fan of Zabbix, that might be cool. Okay, yeah. So that's our what our environment looks like. That's kind of how effectively code goes from origin to online to users. And again, online is free. We're still in developer preview. So, but what is currently free will always be free. And then later in life, you'll be able to buy up for more resources if you need them, or hopefully when you need them, because your site will hopefully go viral and be very profitable. And that's all I have. Questions? I know we had a few along the way, which I was really a big fan of. That was great. Thank you.
Thank you very much.